as we saw in the hairstyling section, we can use the transfer map functionality to transfer UV coordinate over to the hair to be used for texturing. But we can also create a UV coordinate system through render tree to create basically custom effects or specialized texturing effects. So in this case here, we have a branch, and I've applied hair to the sub-branches to basically control the distribution of leaves over the actual branch. So right now I just have regular hair applied, and you can see we're getting that soft, fuzzy look. Not exactly the way a tree looks. So what I'm going to do is quickly go into the hair shader, and what we want to do is let's just bring down the amount to 650, something a little more manageable. And we want to thicken these up quite a bit. So I'm going to set the root and tip to 15. So basically we end up with kind of sprite cards on our branch, which we can apply the leaf pattern to. So when we have something like that, we can quickly draw a region just to see what it looks like. Okay, that looks about right. Next we're going to go into render tree. And what we want to do is actually we're going to use the scalar state node to extract UV coordinates for the hair. So what the scalar state node does is basically it returns a scalar value. So different parameters can be returned, screen position in X or Y, some index of refractions of different rays. What we're interested in is the crosswise hair and lengthwise hair and spline hair and turbulent options. These basically allow you to specify a coordinate system on each hair. So what we want to do is, you can see for each grid, is we want to specify a U coordinate along the width and then a W coordinate along the length. So 0 to 1, 0 to 1 along the entire hair length, and then we can apply basically a single texture to that individual hair. So what I'm going to do is set one of the scalar state nodes to crosswise hair, and I'm going to get another one, a second one, and we're going to set that to lengthwise hair. And now we can combine them and also convert them in the same process using a scalar to vector node. So what I want to do is plug in that one scalar state into input X, which basically represents the U value, and put the lengthwise one into the Y, which represents the W coordinate. And then we can use an image lookup node, and this is basically just the same as a regular image texture node, with the fact that it doesn't include an actual texture coordinate system built into it. You need to provide that. So what we're going to do is plug our scalar to vector node into the image lookup to give it the actual UV coordinates, and then we can plug that into the ambient and diffuse values. And I can just use shift here to multi-select the different inputs. So hopefully that'll give us something a little more appealing. Okay, so you can see where each hair is actually being textured by the noicon.pick now, which is perfect. What we want to do is actually use our leaf pattern. I've got it here already. So we've got a leaf, and I created an alpha channel for it. If we look at the actual alpha of it, we've got that built in already. So we can use that to actually drive the transparency. So that looks about right. What I'm going to do is to extract the alpha, quickly use a color matte node, and just to speed things up, I'll close the region. We'll input that into the color matte node, and basically that allows us to output a channel and do some different things like invert it or multiply it. So we want to output the alpha channel, which is correct, and I'm going to plug that into the transparency here, tip and root. So you can see the transparency on the hair is actually a scalar input, so a conversion node was added automatically. So there we go. It's looking pretty good. The one thing to be aware of is we're going through the hair renderer. So we actually provide two hair shaders, the hair geometry shader, which is more like an adapted geometry shader using a base of like Phong or something like that, and a lot of different gradients to create the hair look, or our hair renderer here, which basically can render in both the volume and geometry mode, and is actually the original shader we had with hair. But for something like this, you can see here we're getting some strange shading artifacts, and that's actually normal because there's a lot of fudging we do in the hair render to get the hair to shade properly. And in this case, what we're doing is we're shading half the hair. So you can see each leaf actually has half the hair, half the leaf shaded a darker color, and that's because for the regular hair it actually works to create a more realistic look. But in our case, we don't really need to use a lot of these hair shader features because they're really designed for distant shots of hair where you're not going to be seeing a lot of detail. So what I want to do is actually, let's just replace that with something like Lambert. So I'll get the Lambert node, and what we want to do is plug this guy into the ambient and diffuse, and I'm going to go out of the color matte and go into the transparency, and then out of the Lambert into the surface node. Let's just update that. Oh, if we didn't have a selection there, update that. There we go. And we can actually replace the shadow and photon port with this guy too. And we actually don't need this guy anymore. I'm just going to disconnect all the inputs. And there we go, a little simpler, and that should give us more or less what we're looking for. So you can see we got rid of the shadow artifacts on each side of the hair, and it's fairly realistic looking. And basically, you know, we can go ahead and adjust this even further by adding some special effects like noise and stuff and fractal patterns to vary the leaf pattern. But more or less, this is the render tree you're looking at for creating individual textures on each hair.